Hello. In this video I'm going to talk about code refactorings in Roslyn. Let me first show you what a code refactoring is. So here in Visual Studio I have a main method, and then here I have some code to write to the console. What I can do, I can select this code here, click this quick actions icon, and then click extract method. This will create a new method called new method with the extracted code as the body of this new method, and then I have a chance here to rename the method. Okay, so this is called a code refactoring, and Visual Studio has many built-in refactorings like this, and they can help us make our code better. So in this video I'm going to show you how to create a code refactoring by using an example. Let me show you what problem the code refactoring would solve. So here inside the doSomething method, I created a parameter of type action of string, and this parameter is called printName. This parameter will be used by the method to print the name Adam, right? However, because we are using action of string, we allow the consumer of this method to specify exactly how to print the name. For example, this consumer uses the console to print the name, but another consumer might write the name to the file system. I myself use the action delegate a lot in my coding, and it's very helpful. And this delegate is generic, and it allows us to use any type for the parameters of the delegate, right? But one problem with this delegate is that we don't get to choose the names of the parameters. For example, there's no way here to specify name as an argument, right? And when we look at this action parameter here, sometimes we are confused about the role of this inner parameter here. So in this case, this parameter represents a name, but this fact is not shown here. So usually I fix this by using a comment like this. And this will enable potential readers to understand the role of this string parameter here. So this comment here will help readers understand this parameter, but it will not enable us to use a named argument like this, right? Okay. So the refactoring I'm going to create in this video will enable developers to change the type of this parameter here into a custom delegate like this. So this will enable developers to see the exact parameters of the delegate with their names, and also it would allow them to use a named argument here like this. Okay, before we get started, I want to say that the example I'm going to show you is a bit complex, and it might be a good idea to watch my videos about creating a Roslyn analyzer first. Okay, let's get started. Okay, I'm going to create a new project, a class library. I'm going to call it create custom delegate code refactoring. Okay, I'm going to add a reference to Microsoft.codeanalysis.c#.workspaces. Okay, let me rename this class. And I'm going to inherit from code refactoring provider. Okay, I'm going to implement the abstract member compute refactoring, I think, and then here I need to apply some attributes. Okay, so in order to create a code refactoring, we must create a class that inherits from the code refactoring provider class, and then we need to apply some attributes here, and these attributes belong to the managed extensibility framework from Microsoft, and I talked about these attributes in the videos about creating a Roslyn analyzer. Now, in order to deploy the code refactoring, we need to create a Visual Studio Extensions project and reference this project. Let me show you. Okay, I'm going to create an empty VSIX project. So I'm going to go to this source.extension.vsix manifest file, go to assets, and then add an asset of type MEF component. The source is a project in the current solution, and then the project is the create custom delegate code refactoring. And as I said before, details about all of this are available in the series about creating a Roslyn analyzer. Okay. Now in this video, I'm going to write tests first. But before I do that, I'm going to create the simplest implementation possible just to show you the very basic steps to create a code refactoring. So here, using the context parameter, I have access to a method called register refactoring, and it takes a parameter of type code action. And I can use the create method of code action to create a code action object. So here I give it the title. I'm going to use create custom delegate, and this is the title that will appear when we click the icon here, right? Okay. And here we need to pass a function that will be called when the user clicks the action. Now here, in the body of the lambda here, we are supposed to return either a modified document or a modified solution, right? If we return a modified document, then that will mean that we want the code refactoring to only do changes to the current document. And if we return a modified solution, then that will give us the ability to make changes to more than one document in the solution. Now, using this simple implementation would mean that this refactoring will be available in all places, which is not what we want, right? We want this refactoring to be only available in the context of some of the parameters, right? And also this implementation doesn't do anything. Okay, so let me show you the code refactoring in action. Okay, so I have set this VSIX project as the starter project, and let me now run to test the code refactoring. Let me open one project. Now, if I go anywhere in the document and click on this bulb icon, I can see create custom delegate here, right? And if I click it, nothing happens. Okay, let's now start writing tests and working on the code refactoring provider. Okay, I'm going to add a testing project. Okay, so in this test, I have a method with a parameter of type action of string, and then I'm using this comment here to help me understand the meaning of this string parameter, and then I'm using this write parameter to write Adam. Okay, so let me show you now what the expected code is after applying the refactoring. Okay, so after running the code refactoring, we expect the updated code to include a new delegate defined in the class with the name write and with a string parameter called first name. Now the name write comes from the parameter name write, but is uppercase here, right? And then first name here comes from this comment. Okay. Now I'm going to write the code that will invoke the code refactoring. So as I showed you in the video about testing Roslyn analyzers, we can use the ad hoc workspace class to create a workspace for testing. So I need to add a reference to the correct NuGet packages. Okay. So this solution will be an empty solution, right? I'm going to create a new project. So as I explained in the video about testing Roslyn analyzers, here I'm creating an in-memory solution and I'm adding an empty project to it called project1, and then I'm adding a C# file to that project called document.cs containing the code, this one here, right? Okay. So here, as I explained in previous videos, the project created here doesn't have any references, even references to basic assemblies in .NET Core or .NET Framework. This is why I added a reference to the assembly containing the object type, and without this code here will not compile. Okay. Okay, so here I'm creating an instance of the create custom delegate code refactoring provider, which is the system under test. And now I will call the compute refactoring async method. So this method takes a parameter of type code refactoring context, and I'm going to create an instance of this class here. So here in the constructor of this context class, we need to pass the relevant document. We also need to pass a span, which the user selected for refactoring, and then we need to pass an action that this method will call when it wants to register a refactoring. Let me show you. So here for the span parameter, I'm going to pass a span that corresponds to this parameter here. So in order to do that, I'm going first to get the document root node. Okay, and from the root node, I'm going to select the single descendant of this node, which is a parameter syntax. Because in this document here, there's only a single parameter. Okay. And then here I'm going to pass the span of the parameter name. So the identifier token here is this one here, right? Okay. And now I'm going to pass a lambda that will be called by the system under test when it wants to register a code action. And the last parameter is a cancellation token, and because this is a test, I'm going to pass cancellation token.none. Okay. And Visual Studio is showing me a warning here because I'm not awaiting this call. So here we expect the system under test to register a code action exactly once, and therefore I'm going to assert for that here. Okay. Next, I'm going to take the registered code action and apply it to the current workspace. So the code action class has a method called getOperationsAsync, and this method returns an array of code action operations. I'm going to take these operations and apply them to the workspace. Okay, so the solution inside this workspace before we apply these operations is empty, right? Because here, even if we update the solution variable here, the solution inside the workspace is not modified. So it makes sense in this case to apply whatever changes we made to the solution and project here back to the workspace before we apply the changes made by the code refactoring. Okay. So now after this code here is executed, we expect the workspace to contain the change document. Okay. And now I'm going to get the text of the updated document. Okay. And then I need to assert that this actual updated text is what we expected here, right? Okay. So let me run the test now. And the test failed. And it failed because the actual updated code is not really updated, right? It's the same as the input code here, right? And this is because we haven't yet worked on the code refactoring provider. Okay, so we have a failing test. Now it's time to work on the code refactoring provider. Okay, so here I'm getting the document and then the root node, and then I'm making sure that the node selected by the user is a parameter syntax node, right? Now I'm going to get the semantic model. Okay, so here I'm using the semantic model to get the parameter symbol. And now I need to make sure that the parameter is of type action or func, right? So here I'm going to create a class to model a func or an action. Let me show you. Okay, so here I have created a class to model a func or an action, right? And this is an abstract class with a private constructor and two nested classes called func and action that inherit from func or action, right? And this means that a func or action can either be func or action, right? Now a func models a system.func delegate and an action models a system.action delegate. And a func delegate has parameters, input parameters, right? And a return type, right? And an action only has input parameters and it doesn't return anything. Now this parameter class is simply a data object that has a parameter name and a parameter type. Okay. Now here I'm going to create a method that, given a type, will see if that type is a system.func or a system.action. Okay. So here I want to use the nullable reference types feature of C#8 and therefore I need to enable it. So here I'm using C#8 and I'm enabling the nullable reference types feature for this project. Okay. So the first thing to check here is that the type here is a name type, because a delegate type is a name type. Okay, and here I'm returning null if the type is not a name type. Now I want to check that this type is a delegate. Okay, now I want to check the full name of the type and compare it with system.func or system.action. So this getFullName method will return the full name of the type. It's not implemented yet. I have prepared it, so I'm going to paste it here. Okay, so I have pasted these two methods here. This overload of getFullName, you give it a namespace symbol and it gives you back the full name, and it works by checking if this is the global namespace. It returns an empty string in this case. Then it checks the parent namespace of this namespace, and if that is the global namespace, then we simply return the name of the namespace. Otherwise, we reuse recursion to get the name of the parent namespace, append a dot, and then the name of the namespace. Now this overload that takes a name type symbol checks first if this type is a nested type, right? If this type is a nested type, then the containing type property will not be null, right? And if that's the case, we use recursion to get the full name of the containing type, append a dot, and then the name of the type, right? Otherwise, we know that the class is not a nested class, and so we check the containing namespace. If the type is contained in the global namespace, we simply return the name of the type. Otherwise, we get the full name of the namespace, append the dot, and then the name of the type. Okay. Okay, so here if the full name is system.action, I'm going to return a new action object, and if the full name is system.func, I'm going to return a func object. Now here I need to pass the parameters of the action, and here I need to pass the parameters of the func and the return type of the func. And before I continue, I want to make sure that I explained what I mean. Okay, so if the parameter type is this action here, then there would be a single parameter in this array, and that parameter will have the type string and the name p1, right? And in the case there's no name here, we will use the default name used by the action delegate, which I think in this case is arg, right? In the case of system.func, here also we have a single parameter of type string and named p1, and the return type is int. Okay. So in order to calculate these parameters, the type here is not enough, right? Because in order to get the comments here, I need to access the syntax node, right? So here I will add the parameter syntax node as a parameter. Okay. Now the source of these parameters will be the type arguments of the func type or the action type, right? So in case of the action type, all the type arguments will be converted to parameters, but in case of the func type, all but the last type arguments are parameters, and the last type argument is the return type, right? So here I'm going to create a local function that when given an index of a certain type argument, it will read its type and any possible name from the comments, and it will create a parameter object with that type and that name. And I will also make it in a way that if there is no comment here, it will use the default parameter name of the delegate. And let me show you these default parameter names. So this is the documentation of the func delegate. And as you can see here, there are multiple func delegates. And for this specific delegate, the name of the parameter is arg, right? For this delegate that takes two inputs, the names of the parameters are arg1 and arg2. Okay. So here I'm just making sure that the parameter type is a generic name syntax, and we expect it to be so because both system.func and system.action are generic types, right? And I'm going to use this type here to get the type arguments as syntax nodes. Okay, so this here will be the syntax corresponding to this here, right? Or this syntax here, right? So first, I'm going to try to see if there's a multi-line comment here. Okay. So I have prepared these methods here, and this try get name from multi-line comment method. You give it a type syntax, which is the type argument in our case, and it tries to see if that type syntax contains a multi-line comment. And if it does, it returns the content of that multi-line comment as a string. Otherwise, it returns null. Okay, so here we are using a method called getTrailingTrivia, and this method returns the trivia at the end of the syntax node. And trivia is basically things like white spaces and comments. So here I'm getting trivia that are of kind multi-line comment trivia, and if the number of trivia is not 1, I return null. Otherwise, I get the single multi-line comment trivia, and then I use this method to get the contents of that trivia. Okay. So here we need to handle the case where this is null, meaning that there's no multi-line comment. Okay. So here, if the name from the multi-line comment is null, I'm getting the invoke method of the delegate, which is system.func or system.action. I'm getting the parameters of that invoke method, and then I'm getting the parameter with the specified index, right? And then I'm getting the name of that parameter. So now we have the name of the parameter, and for the parameter type, we can use the parameter of the invoke method to get the type. Okay. So this local function is ready now. Let me do some refactoring. I want to rename this variable. Okay. So now I'm going to use the local function that we created to calculate this parameter's value. So for system.func, all the type arguments except the last one are inputs, right? So I'm getting those And for each one I'm creating a parameter object that will contain the name and the type. And these are the parameter objects I use to construct this func object here, right? I do the same thing for action, but in case of action, all the type arguments are inputs, right? This is why here I'm taking all the type arguments, even the last one. Okay. So what remains here is the return type in case the delegate is system.func. And we can get this easily by getting the last type argument, right? Okay. Okay. Okay, let's use this method now. Okay. So here I'm calling the try get func or action method, passing the parameter type as a symbol, and then the parameter syntax. And if this method returns null, then this parameter is not a func or an action, right? Otherwise, we register the code action. And here to update the document, I'm calling a method called update document to add and use a new delegate, which I will be creating next. And here I'm passing all the objects that I think I will use. Okay, let me generate this method now. Okay. So the first thing I'm going to do here is to generate the delegate. And to help me do that, I'm going to use the syntax generator class. Okay, so here I created the syntax generator, and then here I obtained the parameters from the action or the func, right? And here I'm using the switch expression from C#8 to do that. Here I'm using the syntax generator to generate a new delegate declaration. And for the name of the delegate, I'm using the parameter name modified to have the first letter be uppercase, right? And then for the parameters of the delegate, I'm using the parameters from the action or the func, and for each parameter I'm using the syntax generator again to generate a parameter syntax. And of course for the names of the parameters in the new delegate, we are using the names that we calculated when we created the func or action object. And of course for the type of the delegate parameters, I'm using the syntax generator to help me create a type expression based on the types we calculated here, right? So another thing I want to specify when creating the delegate declaration is the accessibility of the delegate, and I want to make it public. Okay. So another thing I need to do to the delegate is to add a return type in case this is a func, right? Okay. So now that we created the delegate declaration, we need to change the parameter type of the method to use the type of this delegate instead of func or action, right? Okay. Okay. So here, from the parameter syntax, I'm getting the parent, which I expect to be a parameter list syntax, and then I'm getting the parent of that, which I expect to be the method, right? So this will be the method containing the parameter. And here I'm creating an updated version of the method syntax by using the replace node method. The node I'm replacing is the type of the parameter, which is the action or func, right? And I'm replacing that with an identifier name syntax, which is the name of the delegate, right? So this method will be an exact copy of this method, except that the type of the parameter is the delegate and not func or action. So now I want to update the document to do two things. The first thing is to add the delegate declaration as a member in the class, which contains the method, right? And the second thing is to replace this method node here with the updated method node here, right? Okay, so here I'm getting the root node of the document, and here I'm getting the type that contains the method, right? Which in our test case is the class, right? And here I'm getting the index of the method within all the child members of the containing type. And I will explain why shortly. Now here I want to update the root node of the document to replace two nodes. The method, I want to replace it with the updated method, and then the containing type, I want to replace it with a modified version of this containing type that includes also the delegate as a member, right? So this replace nodes method, it takes two parameters, the nodes that we want to replace, and then a lambda expression. And then this lambda expression will be called by the replace nodes method multiple times. And each time the replace nodes method will give us the original node that we wanted to replace, which will be one of these two nodes. It will also give us another node object, and this node object might be the same original node, or it might be the original node but updated. And let me explain exactly what I mean. So for example, let's assume that this method started updating this node here, the method node, right? So what will happen next is that this lambda will be called, and the value of these two parameters will be this method node here, right? And let's say here that I return the updated method, right? So now the replace nodes method wants to process this containing type node here. This lambda will be called again. This original node will be the containing type node as is, but this possibly changed node will be the containing type node updated because of the update that happened to the method node, right? The first iteration that worked on the method node will cause an updated version of the containing type node to be created, and that is what will be passed as a value for this parameter here, right? Okay. Okay, so in the iteration where we are replacing the method node, we simply replace it with the updated method node, right? Now in the iteration for the containing type node, we first cast the possibly changed node into a type declaration syntax, because we know it has to be a type declaration syntax, right? And then we get the members of this type declaration syntax and add the delegate declaration as a member. But here we use the index of the method so that the delegate is inserted before this method, right? and then we return an updated version of the containing type that has the updated members, right? So here I have to throw this exception to satisfy the lambda, and I know that this exception will not be thrown because the original node will be either method or containing type. Okay, so why did I have to deal with the possibly changed node in case of the containing type but not in the case of the method? And the reason is that in the case of the method, we want to replace the whole method with the updated method node. But in the case of the containing type, we only want to modify part of the containing type. That is, we want to simply add a new member, which is the delegate declaration, right? And the other part that we don't want to replace inside the containing type might have been changed if the first iteration updated the method, because the method is one member of the type here, right? That is, here, the possibly changed containing type.members will contain the updated method, right? But if I use the containing type directly here, this containing type.members will include the method node, not the updated method node. And this will cause this update here to be lost, right? So now that we have the updated root node, we can return a modified document. Okay. Okay. Let's run the test again now. Okay, and the test failed. And here the actual code is not changed. And I did some debugging of camera, and I found two problems in the test. And here in the test method, after updating the workspace, I'm using the project object here, and this project object will be different than the project object inside the solution, which is inside the workspace. And I talked about this in a previous video, which is when you call try apply changes and you give the workspace a solution, don't expect the workspace to use the same solution object. I don't know the exact reason why, but after calling try apply changes, the solution object inside the workspace will be a different object than the one we give to the try apply changes, although the contents will be similar. So to fix the problem here, I will simply get the project from the workspace. Okay, and the second problem I found is simply a formatting issue. Here I have an extra line in the code. Let me now run the test. And the test passes. Great. Because I had to fix the test itself to make it pass, it's a good practice to go back to the system under test and make the test fail because of a change in the system under test itself. So here I'm intentionally returning the same document, and this will cause the test to fail again. Okay, as expected, it failed again, and the actual code is unmodified. So now I can trust the test again. Now here I will fix the system under test. Okay, so let's see the code refactoring in action now. Okay. Okay, let me click the light bulb here, create custom delegate, and here it shows a preview of the changes. Okay, and here it created a new delegate and used it here. Okay, so let me undo the changes and let me show you something here. So here the main method calls test2 passing the lambda, and then test2 calls test1 passing this parameter, the right parameter, right? And then test1 uses the right parameter. So here if I go and then create a custom delegate, the delegate was created and the parameter type was changed to write, but here in the calling method we have an error because action of string is not assignable to write, because in C# delegates are not assignable to each other even if they have a similar signature. It would have been nice if the code refactoring also changed this parameter to have the type write. And this is something that we will do in the next video. Okay, thank you for watching.